Good morning, everyone. Today, I'm going to talk about how voice agents engage customers in multimodal interactions. I organized my talk into the following sections. I will first talk about the interaction modalities on Alexa devices, and also look at the history as well, history of human-computer interactions. And I will also briefly talk about what are the customer experience attributes that we bake into features and skills that we add to Alexa. And I will introduce blended results here on multimodal devices. We will peek under the hood to see what AI capabilities are powering blended results. From the developer's perspective, I will explain how developers can participate in blended results, how they build experiences. And this actually opens a new opportunity for skilled developers and enterprises to get new traffic from Alexa interactions. So I will talk about that. Time permitting, we will have Q&A. Okay. If you look at the Alexa devices that we launched, let me take a moment here, maybe a minute or two, to look at the history. The computers are in our lives maybe last 50, 60 years. And actually, the first computer was invented by Steve Wozniak in 1976. And it had monitor, it had keyboard, it had motherboard. Since then, we had in the 80s PCs, and we have desktop PCs with the internet. And then we have mobile internet right now. When you look at it, the interaction, human-computer interaction with computers have been primarily with touch and typing modality. In other words, you need to literally touch the computer to be able to interact with the computer, providing manual input. And this has changed. This has changed in 2014 when we launched Alexa devices. And with Alexa devices, the modality changed from typing and touching to voice modality. And this required bringing three technologies together. One was abundance of data that we are getting from the environment, from interactions to train the AI models. The other one was abundance of computing power. And the third one was invention of deep learning algorithms to harness this data to improve speech recognition, natural language processing. So they all came within Alexa with the 2014 launch of Echo and Alexa agent. So that was the paradigm shift for us, that the society and the users are getting into a new interaction paradigm with the computers. And since then, we build new Alexa devices for different situations that the customer is in. And you will see we invented and launched multimodal devices with screens. And if you compare these two device families, the one on the left, you see what we call headless devices. It doesn't have screen. Voice is a natural input to interact with these agents and computers, because you don't need to learn anything. Everyone speaks the language. If the system is good enough to recognize the speech and understand the text and fulfill the task, that is great for customers. You get things done. That's a faster way of communicating from human to AI. But when you look at different use cases, though, that sometimes voice out, meaning that speaking out is not the most effective way for certain tasks. That's why when we have a multimodal devices, it's sometimes more effective to present a set of results. And human looking at the set of results on the screen, that they can consume that information much faster. So we are adding capabilities on the perception side, bringing visual understanding, touch, and gestures in the future. And also on the output side, how do we present this information? And that is what blended results is about. It's enriching the multimodal interactions with the customers. So here, when we launched Alexa in 2014, we had to be great on 4 fundamental AI tasks. And these were wake word detection, speech recognition, natural language understanding, and text-to-speech. Let me briefly explain what these AI tasks mean. Wake word detection was Alexa is there somewhere in the room. You should be able to get Alexa's attention by using a wake word. And Alexa is listening for this wake word to see whether the customer, the user, is addressing Alexa. And you need to make sure that that's highly accurate. So there's false precision, false accept problem here. The system should be highly accurate to detect that, yep, this request is addressing me. It shouldn't wake up for side speech or requests that aren't directed to Alexa. And the second one is once you get Alexa's attention, the automatic speech recognition, you start speaking to Alexa. We have the Alexa Voice Services platform which orchestrates getting the audio, sending to from wake word to speech recognition systems. Speech recognition systems takes the audio and transcribes the audio to generate a sequence of words. It's text. We still don't know the meaning of these words. And that goes into the natural language understanding. There we understand the customer's intent, the slots that in the request entities the customer is talking about. To give an example, how Alexa, how's the weather in Las Vegas? You know, Alexa, keyword detection, wake word detection, detected the word Alexa there. Now it's streaming the audio to the speech Alexa service. And then that audio is sent to speech recognition that we get the text, Alexa, how is the weather in Las Vegas? And there in natural language understanding, we get the customer's intent here. The intent is get weather forecast. But we also tag the entity Las Vegas. It's a location. So natural language understanding takes the intent and also the entity and resolves that actually Las Vegas is a city with this latitude and longitude, and it calls backend services to get the real weather request. It's, I don't know, it's maybe 95 degrees, it's pretty hot here, lows and highs, and that information is actually sent to the application. That information is taken from the application, and the response is synthesized through a text-to-speech engine, meaning that the request, actually the response, the weather in Las Vegas is 95 degrees. There needs to be an audio generated, and that is what the text-to-speech system does, and that audio is rendered on the device to speak through Alexa's microphone to the customer. This is in a nutshell how the system works. Of course, it's a lot complicated than that, and we have many more AI tasks besides these fundamental core AI tasks. So when we add a skill or enhance the Alexa's capabilities, there are these core elements or traits that we add to Alexa. Everything that we build, everything that we launch, everything that we teach Alexa, every skill we add to Alexa, it enhances at this one of these areas. And what are those? The first one, let me start with being competent. Alexa is getting competent with each feature launch, with each skills, with each capability improvement to answer more requests, to know, expanding its knowledge base, to get more things done, and also to learn faster and better and adapt to customer, to be more competent. This will improve customers' dependence on Alexa, and it will make Alexa a dispensable assistant for the customer. We do it on there is the AI part in this. We build large language models, pre-trained language models. We do multitask learning, deep learning models to improve Alexa's intelligence. The next one I would look at is natural and conversational. Just like you're communicating with a human being, Alexa should be able to understand the customer's context and seamlessly carry it over from one turn to the other. This is super difficult to do it with the machines. With human, I can carry on a conversation with someone for 10 minutes, but it's very hard with the machines. So we have a number of inventions in the context area, understanding the customer's context, not only the discourse history and dialogue history, but also the ambient context. The other one is insightful and proactive. We designed Alexa not just to respond to customers' requests, but we also want Alexa to be more proactive, instantly available when customer needs something from Alexa. And that's where insightful and proactive comes to play. We already actually do it. There are Alexa hunches that we launched. In the evening, if you forget to lock the door, Alexa will tell you, I think you forgot to lock the door. You want me to lock it. Or another example that I like is, how long does it take to boil an egg? We predict that the customer probably wants to set a timer. And we say, do you want me to set a timer for 10 minutes, assuming that it takes 10 minutes to boil an egg? All the customer needs to say is yes. With everything here, the personalization is key. We want Alexa to adapt to the customer, not customers adapting to Alexa. So for that, we need to learn the customer's affinities, the actions that they take with Alexa. We also allow explicit personalization, that the customers actually teach their affinities to Alexa, things that they like, their sports team, recipes that they like, to Alexa, so Alexa remembers that. Next time when Alexa is answering their requests, it keeps that personalization element in mind in responses, and that's different for each person. The other area is trustworthy, and we want, just like we cherish trustworthy people, that they're being transparent, they're being reliable, they're being ethical, they're being fair. We want to bake and ingest these attributes to Alexa interactions as well. And we build platform capabilities to make sure that Alexa is implementing these traits, that we, it's non-negotiable in human-human interactions, and it's as important for us in human-machine communications as well. The missing piece here was multimodal interaction. With the launch of multimodal devices, we also want to make sure that we just don't handle voice input. We also handle multimodal interactions. That's how we communicate. We just don't use our voice. Just like I'm talking, I use my gestures, I use my facial expressions. So that would make the interactions more natural. And as I said, there's the perception side and there's the output side. When Alexa is also providing answers to the customers, we also want to use the screen on multimodal devices to give richer responses to the customers so that they get more utility from Alexa. All of these building blocks or elements are foundations for our ambient intelligence vision for Alexa. Ambient intelligence here is Alexa is ever present in the physical environments that you are in, and it's ready to answer the questions that you may have. But it's also taking initiative to engage with the customers when it needs the value or need to help the customers. But otherwise, it recedes to the background. Just like you get into a room, you know that there is electricity in this room. We like to turn Alexa into like electricity. It is a utility. It is everywhere that you need in physical spaces, and there to help you, to make your life easier for you, to make you more productive. Now, let me introduce blended results. So what you will see here is the current user experience, or customer experience. Today, when you ask Alexa how many calories are in an avocado, this is the answer you get on, say, Echo Show 10, Echo Show 15. These are multimodal devices. You get the right answer, single answer. With blended results, this is what you will get. You will get the right answer, 320 calories, but we will show you other relevant answers as well. And This is the thing when someone is asking about avocado, they may be curious about avocados, how many calories, but they may have other things also. Everything that what we are doing is, what are the things that they may want to know about avocado? Well, they may be interested in making avocado recipes. They may be interested in shopping for avocado. So we want to enrich this experience by bringing other relevant results. The skills that Alexa has, actually, the customer may not know about them, to enrich this interaction so that the customers find the answers that they're looking at. They may not even know that Alexa actually is capable of answering those questions. So there's the exploration element here too, so that the customers are aware what Alexa can do for them. Moving to the next one, here is a demo. The customer is asking Alexa, order pizza tonight. So what you will see here is, after you play, there is actually a personalization element. We learned that the customer is a vegetarian. So let me play this first.
Alexa, order pizza tonight.
Okay, let's see what's available to order. Starting with grocery delivery from Amazon Fresh. 365 margarita thin crust frozen pizza. And here's more related to order pizza.
Alexa, extreme pizza.
Extreme pizza, all right. If you want this one, you can say, order from Yelp.
Yeah. So what you see here is, the request is a bit ambiguous, like order pizza tonight. We don't know what customer wants, so we sort of gave possible options that we think that the customer would be interested. We also gave the relevant results, as in customer is vegetarian. We only show the vegetarian options to the customer. It's clearly enriching the interaction with Alexa and leveraging multimodal device screen as well. So here, if you lift the hood and look underneath, what is powering blended results? These are the core building blocks that we need to implement on the AI side. First, we need to be, our system needs to be context aware, meaning that Alexa needs to take the dialogue context into account, the ambient context the customer is in, and the customer's preferences as well. And the other problem that we had to solve, AI problem that we solve, is unlike giving one answer to the customer, we like to give multiple answers, multiple results to the customer. And now, with that, you're bringing in like first-party answers or results that Alexa is generating. There's third-party skills that are contributing to the answers as well. So there is, even the interpretation, it itself could be actually ambiguous. There may be multiple possible interpretations for this. And when you say, Alexa, order me pizza or get me pizza, is it shopping or something else? So you don't know. So there are multiple things that we need to select from, sourcing the candidates, but we have only a limited space to show them. And the other problem is selection and composition. As I said, we may get 15 results from different content, but we can only show 3. We can only show 4. That we are implementing deep learning-based rankers, multi-arm banded models to model these interactions and learn from the customer interaction. Self-learning is a new area that we pioneered. And here we don't use annotated data. We completely rely on customers' interactions and latch onto their implicit and explicit feedback to teach the AI algorithms to know what is right, to know what is wrong. If there is a defect, how do we recover from it without doing any manual annotation and intervention? So here is an example. Customer says, where can I find garden tools? There may be, as I said, multiple interpretations of this request. Customers, maybe want to do a local search on garden tools, like local stores. They may be shopping at the Amazon store. Or they may be simply wanting to know more about the garden tools. So there are different interpretations, not one. And not only that, there may be follow-up actions that they may want to watch learn about how they care about the garden tools, or how they, they want to shop for garden flowers. That's why they're looking for garden tools. Or they may be an advertisement opportunity as well for garden tools. So these are all the possibilities that the customer may want to know. And as I said, the options that we need to show, the results that we need to show the customer is a lot more than what we can show. So there's the presentation part. So what is the best option to present information on these devices? And also the skill capabilities, what skills can do. These are different layouts that we can do. Present, how do we present the information? Do we present 6 or 3 or 5? And what are the, the sizes of these tiles? So that's an optimization problem. And we solved that as well. So we decide on what is the short list of candidates that we need to choose from. And how do we present this information in an optimal layout? And that goes on to multimodal devices. And here, if you look at it, who are contributing to blended results? Well, we have built-in skills, first part of the skills that we mentioned. We have enterprise skills, like we put Alexa in Disney, in Hilton, Marriott hotels. The customers actually interact, senior care, they interact with these, with Alexa. And there is third-party custom skills they build, and there's also sponsored content. So they're all participating into providing this content candidates for blend to be shown to the customer as part of blended results. So we source the content from the content providers, and then we shortlist them, choose the ideal subset, the optimal subset of the content based on the device and skill capabilities. And then we determine the optimal presentation with self-learning baked in again. We learn from the customer's interactions, we experiment, we play with different layouts, and to see what's leading the most engagement with the customer. And underneath is the learning algorithms, and to provide the most relevant and personalized results across skills, and also maximizing customer delights and reducing interaction defects. So the question is, from the third-party developer side, how can I participate in blended results? Well, we will make it very easy for the developers. This is actually what you are showing here. What we are showing here is Alexa Developer Council. If you go to this website, you will see that how the third-party developers build interaction models, third-party skills to integrate with Alexa. What we are doing here is adding some boxes here that they need to specify the different viewports on these different devices. And device, Alexa multimodal devices come in different shapes and forms. The screen sizes are different. So all they need to do is implement the viewports that they support and check those boxes. And then when we are handling customer requests, we know what skills support what viewports on what devices, so that they're considered as part of the ranking algorithms. And not only that, we will also provide the customer insights for the developers who are participating in blended results. We will show them the engagement, the traffic, the CX frictions and defects the customers are experiencing, the engagement lifts that they are seeing, so that they can look at the analytics dashboard and see, get an insight on the customer interaction or things that they need to improve to maximize their engagement with the customer. Yeah. So here, if I summarize the value of blended results for skill developers, well, it will increase their chances of getting discovered. Let me pause here for a second, actually. On non-multimodal devices, the customer's attention span is maybe 15 seconds, 20 seconds, or a minute. So we need to fit in everything to that attention span. We don't have that on multimodal devices. On multimodal devices, we can show 3, 4 results. So the opportunity, or the bandwidth rather, to communicate with the customers is increasing. So that will give more, increase the chances of getting discovered for third-party skills, so that the customers know that there is this skill relevant and I can do this with this skill. So that is one thing. Getting a discovery is one important difference for developers. And then it may also create increased revenue opportunities for them and the enterprises as well. And this is, as I shown, it's a simple extension to skill implementing the skills and onboarding the blended results. So we make that as seamless as possible. For the end customers, when we are answering customers' requests, we want to make sure that we not only answer the customer's request accurately and precisely, we want to also show everything the customer may want to know or want to do for the entities that they're asking. And so the relevancy of the results and allowing exploration and with follow-up actions is what we support with blended results, and contextual follow-up actions. And it also, customers can navigate from one turn. It naturally leads into multi-turn dialogue, multi-turn interactions. And the results will be personalized over time through self-learning algorithms that we implement. Here, I will show you a few more additional scrappy demos that we built. Let me play them.
Alexa, what are some meditation techniques?
Here's something I found on the web. According to the termpaperwarehouse.com, there are various techniques of meditation such as breath control, mantras, and single-pointed concentration.
Alexa, I would like to try Headspace.
Would you like to begin today's meditation?
Yes.
Beginner's mind is something to bring to every moment in life, not only to our meditation. So whether you're watching the breath or eating some food, be curious, as if for the first time.
Alexa, order a pizza for me tonight.
Here is margarita thin crust pizza from Amazon Fresh.
Interesting.
I can help start a restaurant reservation using OpenTable. Would you like to continue?
Yes.
Here we are
Sending
showing
booking info to your
multimodal
phone.
interaction through touch.
You can find the notification in the Alexa app by scrolling through your notification history.
Alexa, how many calories are in avocado?
Avocado has 320 calories.
Alexa, show me the first one, please.
Here's your recipe.
Great.
Thank you for listening and joining the talk.